Good morning students. In this lecture 20th of electronics, we will discuss various types of negative feedback circuits. As in the previous lecture, we have already discussed about the general theory behind the feedback, and while studying that general theory behind feedback, we have considered voltage series feedback amplifier. The block diagram which we have drawn, that was voltage series feedback amplifier, where the inputs of the amplifier and the feedback circuit, they were connected in series, and the output of the amplifier and the feedback network, they were connected in parallel. So today we will discuss that what are the various types of negative feedback circuits, and why in that previous lecture why we considered voltage series feedback amplifier. So there are two types of negative feedback circuits, and those two types are voltage feedback circuits and current feedback circuits. So negative feedback circuits, they are of two types: voltage feedback and current feedback. And these two types of feedback circuits, they are further divided into two types. Voltage feedback circuit, it is divided into voltage series feedback and voltage shunt feedback. Similarly, this current feedback circuit, it also have its two types: current series feedback and current shunt feedback. And now we will discuss all four types one by one, and in the end we'll come to know that why we have used voltage series feedback amplifier while studying general theory of feedback. Now, why these two circuits, they are known as voltage feedback circuit? Because in these types of feedback circuits, voltage feedback from the output of the amplifier is proportional to output voltage across the load resistance. So in this type of feedback circuit, the voltage feedback, that is VF, it is basically proportional to the output voltage of the amplifier across the load resistance. But in case of current feedback circuits, the voltage feedback VF from the output of the amplifier, it depends upon the current flowing through the load resistance, or you can say that it depends upon the output current which is flowing through the load resistance. And one more difference in the two, that is, in voltage feedback circuits, the feedback network, it is always connected in parallel with the amplifier, in parallel with the output of the amplifier. In voltage feedback networks, output of the amplifier, it is always connected in parallel with the feedback network. And in case of current feedback circuits, the feedback network, it is always connected in series with the output of the amplifier. So this is the one big difference in current feedback circuits and in voltage feedback circuits. In voltage feedback circuits, the voltage feedback from the output of the amplifier, it is proportional to the output voltage across the load resistance. And in case of current feedback circuits, the voltage feedback VF from the output of the amplifier, it is proportional to the output current flowing through the load resistance. And second thing is that in this, the feedback network, it is always connected in parallel with the output of the amplifier. And in case of current feedback circuits, whether it is series or whether it is shunt feedback, the feedback network, it is always connected in series with the output of the amplifier. So first type of discussion is voltage series feedback. So here I have drawn the block diagram of voltage series feedback amplifier, where we have, this is the amplifier section, and this is the feedback section having feedback factor beta, and this is the amplifier having gain without feedback A. VO is the output voltage across the load resistance RL. VI is the resultant input to the amplifier with feedback. Vs is the input voltage without feedback, and Vf is the feedback voltage. And we know that this Vf, it is equal to beta V naught. So now we'll discuss this. Here you can see the output of the amplifier and the feedback network, they are connected in parallel. How? This end of the amplifier, output of the amplifier, it is connected to feedback network, and other end of the amplifier, it is also connected to the feedback network. So both ends of amplifier and output of the amplifier and the feedback network, they are connected to one another, means connections are in parallel. So now see the input side. On the input side, one end of the amplifier, it is connected to the one end of the feedback network, and the other ends of both, other end of amplifier, input of the amplifier, it is connected to Vs, and the other end of feedback network, it is connected to Vs. It means only one end of amplifier and the feedback network in case of input side is connected to one another. So input side is, on the input side, the amplifier and the feedback network, they are connected in series, and on the output side, the amplifier and the feedback network, they are connected in parallel. So that is why here I have written down that they are connected in amplifier and the feedback network, they are connected in series parallel. So input, on the input side they are connected in series, and on the output side they are connected in parallel. And this is also known as this voltage series feedback amplifier. This is also called as shunt driven series feedback. How? Because in case of this feedback network, feedback drives feedback network. Feedback amplifier जो है बच्चे इनू कौन चलाਉਂਦਾ? Feedback चलाਉਂਦੀ है. And what about the feedback here? Here the feedback network, it is connected in parallel with the output of the amplifier. Means the feedback network, it is connected in shunt with the output of the amplifier. And this shunt feedback, it derives this whole amplifier. Feedback is given back to this input of the amplifier through this shunt connection. So that is why this is known as shunt driven, because this shunt provides feedback in series to the amplifier. So that is why it is known as shunt driven series feedback, because of the shunt connection of the feedback network with the output of the amplifier, feedback is provided in series to the input of the amplifier. And then the shunt connection decreases the output impedance, and series connections increases the impedance. Why? Because we know that suppose you have two resistances, first resistance is 2 ohms, second resistance is 5 ohms. If the two resistances, they are connected in series, then what will be the equivalent resistance? It will be 7 ohms. And if these two resistances, they are connected in shunt, they are connected in parallel, then what you will get? 5 into 2 by 2 plus 5 means 10 by 7. So equivalent series resistance, it is higher than parallel. And later in the applications of advantages of negative feedback amplifiers, we have one article in which we'll discuss in detail that how the shunt connection, it decreases the impedance and series connection increases the impedance. We will study the general article, general theory behind this. So here, So as you can see, on the output side we have shunt connection, and shunt connection, it decreases the impedance. So shunt connections at the output, they will decrease the output impedance, and series connections at the input side, they will increase the input impedance due to feedback. So this is all about voltage series feedback amplifier. Next comes second type of voltage feedback circuits, voltage shunt feedback. So first of all, here we have the block diagram of voltage shunt feedback amplifier. Here you can see the output is always connected in output of the amplifier. It is always connected in parallel in shunt with the feedback network. But why it is called voltage shunt feedback? Because the inputs are connected in parallel. The input on the input side, the feedback network, it is connected in shunt with the input of the amplifier. So that is why it is known as voltage shunt feedback. So here you can see this end of the input of the amplifier, it is connected to feedback network, and other end of the input of the amplifier, it is also connected to feedback network. So both the ends of the input of the amplifier and the feedback network, they are connected to one another. So on the input side, they are connected in parallel, and output side, because it is a voltage feedback circuit, so it will always be connected in parallel. So that is why I have written down here that they are connected in, both of these, they are connected in parallel. And this is known as shunt driven shunt feedback. Why it is known as shunt driven shunt feedback? Because the output of the amplifier, it is connected in parallel with the feedback network, and this will provide, this is the shunt, and this shunt feedback, it will provide the feedback to the input of the amplifier, which is also connected in shunt with the, in parallel with the input of the amplifier. So that is why it is said that it is also called as shunt driven shunt feedback. Outputs are also parallel and inputs are also parallel. So here we have, in case of input as well as in case of output, we have parallel connection, shunt connection. And in parallel connection, impedance decreases. So in voltage shunt feedback amplifier, because of the shunt connections, input impedance as well as output impedance both decreases due to feedback. And here, as well as in the previous, because this is voltage feedback circuit, so here the fraction of output voltage, which is known as feedback voltage, it is connected in parallel with the input voltage. Here the fraction of output voltage, that is feedback voltage, it is connected in parallel with the input voltage. That is why it is known as voltage shunt feedback. And next we'll discuss the first type of current feedback circuits, which is current series feedback. And we know that in current feedback circuits, the output of the amplifier and the feedback network, they are always connected in series. So here you can see that one end of the output of the amplifier, it is connected to one end of the feedback network, but the other end of the output of the amplifier, it is connected to load resistance, and the other end of the feedback network, it is also connected to load resistance. So both the ends are not connected to one another. So that is why the connections on the output side, they are in series. And in case of current feedback, it is the fraction of, because this feedback which we are providing here to the input of the amplifier, it depends upon the output current flowing through the load resistance. That is why it is known as current feedback circuit. So here the fraction of the output current which is given as feedback, it is combined in series with the input voltage. That is why it is known as current series feedback. So here you can see on output side in current feedback circuit, both are always connected in series. And here in case of current series feedback, the input side is also connected in series. One end is connected to one another and other end is connected to Vs, input signal voltage. So that is why it is known as series driven series feedback. So that is why it is also known as series driven series feedback. Here the input side and the output side both are connected in series to one another. And as both the input side and the output side, they are connected in series, means on the both sides, the amplifier and the feedback network, they are connected in series, and in series impedance increases. So in this case, the series connection at the input, it will increase the input impedance, and the series connection at the output, it will also increase the output impedance. So both the input impedance and the output impedance increases in this case. And now we'll discuss current shunt feedback, our last type of feedback circuits. So here we have the block diagram of current shunt feedback. Again you can see the output of the amplifier, it is connected in series with the feedback network because this is the current feedback circuit. And the fraction, here the fraction of the output current, it is combined in parallel with the input of the amplifier. So this feedback, it is the Vf is the feedback voltage which depends upon the output current flowing through the load resistance RL. And the output side, one end of the amplifier, it is connected to one end of the feedback network, and the other ends of the two, they are connected to RL. So output section of the two, these are in series. And what about the input section? Because this is current shunt feedback, it means the feedback, it is connected in shunt or parallel with the input voltage or input of the amplifier. So here you can see both ends of the input of the amplifier and the feedback network, they are connected to one another. So the input side is in parallel. So that is why it is said that it is connected in parallel series. And this is known as series driven shunt feedback. And because on the input side, the input of the amplifier, it is connected in parallel with the feedback network. So this parallel connection, it will decrease the input impedance. And on the output side, the output of the amplifier, it is connected in series with the feedback network. So this series connection, it will increase the output impedance. So now we have discussed all the four types of feedback circuits. And now what will be the conclusion from all these four? It is that series feedback, it always increases the impedance, and the shunt feedback or the parallel feedback, it always decreases the impedance. And we have seen that in current feedback circuit, the output section, it is always connected in series. It means in current feedback circuits, there will always be an increase in the output impedance. And in voltage feedback circuits, the output section is connected in parallel. So that is why there will be decrease in the output impedance. And in most of the multi-stage amplifiers, what is required, that all of or most of the multi-stage amplifiers, they require high value of input impedance and low value of output impedance. And now once again, read the results of all the four types of feedback networks and see out of these four, which one is fulfilling this requirement of high input impedance and low output impedance. You will see that only one type of feedback circuit, that is voltage series feedback circuit, first type, it was having high input impedance because it has increased the input impedance and it has decreased the output impedance. So only voltage series feedback, it fulfills the requirement of high input impedance and low output impedance to use it as multi-stage amplifier. So this is all about this lecture, and in the next lecture we will discuss about the advantages of negative feedback amplifiers.